All right, welcome back. We're going to up the complexity a little bit here. So at the moment, the only information that we have, looking at this graph here, is what the task notation is and how long it takes. We also have a bit of information about the progression through the path. So these arrows here mean that I cannot start E until I have finished B and C, right? I can't prepare the room until I've moved the furniture out of the room and I have bought the material to start working on it. So what we're going to have, and I'll put a little bit of a reference at the top, is a six-way piece of information. So in the top left-hand column, we have whatever the task denomination is, so A, B, C, etc. Then we're going to have how long it takes, so the time. And then we're going to have the earliest start time. So ES, earliest start. And then latest start. So LS is latest start. Earliest finish, latest finish. This is all about project management, so knowing when things need to be finished and when they need to start by. So what I'm going to do is I'm going to start off with A here, that's just my beginning, right? And I move up into this here. So this is going to be B. B takes 30 minutes. And because B doesn't depend on anything, right? There's no arrows apart from starting. The earliest it can start is 0. If it starts at 0, the earliest it will finish. Oh, I've got those the wrong way around. Hang on. That's the earliest finish and the latest start. Okay. So back down here, the latest it will finish is 30. Now we're not going to fill in the bottom two until we've done the whole chart. But below that, right, we can do C. Now yours is probably going to look a lot neater than mine. 0 and 20. And then D, it's the same thing. And the reason that we're going to concentrate on the best case scenario is that we are allowed to make assumptions, right? As long as we're clear and specific about what those assumptions are, we can make them. So those are some arrows. Now B moves to both, A and E. So what I may even do, right, just to make it a little bit neater, is I can move this around. Okay. So we've got now E here and F here, E and F. And we're just going to make sure this makes sense. So C goes to E, B goes to E, B also goes to F, and D goes to F. Okay, so E goes to G, F goes to H, G goes to I and J, and I haven't actually written these down. H goes to K and L. I wonder if these are going to be big enough for me to write in. So that's I, J, K, L. These two go to M, and this one goes to N. All right, so let's go back to start now, and these go to finish. All right, so G, let's fill in these. Okay, So this is another way of doing our network diagram. So E takes 15, F 15, G 40, 40, I is 15, and 240. Oh dear. Okay, 15 and 240. All right, M is 15, and it's 15. Okay, and so don't forget, we already kind of have our pathway through, which is, or one of the pathways through, which looks like that. And we have the other one as well, but either of them were on the critical path. So what that means and why that's important will be clear later. So let's look at E. The earliest E can start is 30, because even though C finishes at 20, I have to wait until both C and B are finished. So I start with the later start time, or the later finish time of the previous. 45 to 85. So this is 85, 85. Okay, oh dear. So again, 100 and 325, so 3, 2, 5. And that's going to finish at 3, 4, 0. Okay, let's go down the bottom. It's going to be a carbon copy. Let's give ourselves a bit more room here. Okay. All right. So now what I'm going to do is what's called zipping backwards. So I'll start at the top. I'm going to start at the last task because I'm looking at the latest finishing time. So if I want to finish it within that minimum time, what's the latest I can finish? Well, the latest I can finish this is 340. It's on the critical path, right? So I've got, once more, I've got a critical path here, going there, 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 to the finish. And I also have, this is going to be a little bit confusing because that's going to be green now. That's okay. We all know our colors. All right. If it's highlighted, the top is going to be the same as the bottom because there's no wriggle room. There's no wriggle room there. So 3, 2, 5, 85. Right? Because even though I can finish this at 100 minutes, it doesn't matter if I finish at 100 minutes because I still have to wait for this. Right? M can't start until I and J are done. So the latest I can finish I is at 325, which is when this has to start. Oh, that's 325. Which means the earliest I can finish this, 325 minus 15, is 310. Now we're going back here. Okay, again, let's go that path first. So this one here, even though it finishes at 20, the latest I can finish it is 30. So I'm still waiting around for it, which means I can start at 10. And that's going to be the same for the other one. So let's start back here. We've got a similar thing going on. Okay. The last thing we need to do is to figure out what's called float and the total float time. So what I'm going to do is I'm going to draw a little bit of let's do it with gray. I'm going to do a little bit of a table. for all the tasks over here. We're going to have whatever the task is, and we're going to stick with the letters, as it were. Okay, and you'll see why I'm doing this in a moment. Let's move that down. We've got the time, how long it takes. We've got our start time. We've got our finish time. And we're going to have earliest start and latest start. Earliest finish, latest finish. Let's make this nicer. Okay. Nicer. Now my float. And lastly is this task on the critical path? All right, so A, B, C, D. Now because I'm doing this on this, I hope this is not a mistake. J. All right. So we're not going to worry too much about A, honestly, because A is just beginning the whole thing. All right. So I'll begin filling this in, but really all I care about are these two questions, or these two columns over here, the float and the critical path. So A or B is on the critical path. Yep. C is not on the critical path, so I put a no there. D is also not on the critical path. But everything else is, apart from I and K. Right, so and this matters because if there's any hold up in either of the, if there's any hold up on a task on the critical path, it will push out the timing. Now, because there are two critical paths here, right, we have made it so that there's a bit of redundancy, right? Just because there's a bit of a hold up on one of them, we can problem solve. The efficiency gain is going to be twice as good if we can figure out how to solve these things ahead of time. The next thing I want to figure out is my float. And the float is that thing I called wriggle room before. So if we look at I, there is a big gap between the earliest starting time and the latest starting time. And the float, you can look at either one, but the float is going to be equal to the latest finishing minus the earliest finish. So for B, there's a difference of 10. If it's on the critical path, if it's on the critical path, there's none. So sorry, C has 10. 10. Nothing, nothing, nothing. There's no wriggle room. I has heaps, right? It's got 125. We've got a lot of waiting around there. No, 125. So the total float for this is 270 minutes. So there's a lot of time up our sleeves. In the next video, I'm going to talk about scheduling and how we can use this information to answer some of the questions they had previously, such as how much faster the painters might complete the task and any real-world limitations that may restrict them. Notice it doesn't say how many painters there are, and that's what we're going to talk about